Hi everyone. In this given problem statement, we have to solve word break. Given a string and a dictionary of string word dict, return true if ace can be generated into a space separated sequence of one or more dictionary word. So basically, we have to check whether ace can be formed by joining the words that are present in the word dict. So a simple way of solving this problem, if you have an understanding of prefix tree, you can use this. But in our case, right, we are going to have to use dynamic programming because this problem is a part of 1D. So here, right, what we are going to do, right, we are going to count in. So how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So what I'm going to do, I'm going to create an array which is going to contain 8 values. Let me do it. And I'm going to create another one. This is going to be our base case, right? And here I'm going to say maybe I will just add 1, and for all the others I would be initializing them with 0. Once that is done, right, I have to do one more thing. Here I have to loop through this list from the reverse order. So my current I index will be at position 7, 6, 7, and there are 8 characters, and our position would be, because there's 0 indexing, right, it would be at 7. Now I am going to loop through word dict. So the first letter that I'm going to check, right, it's going to be lead. So here I'm going to check for 0. Does Here also I can add one more condition, which is I plus the length of word that I'm checking, word from this one. If it's greater than our n, right, in that means it is going to go out of bounds. If it goes out of bounds, then there is no way we can match it, right? So in that case, right, for the first condition, right, we would be not able to find a match. So what we're going to do, we are going to basically shift it to one more position. So here I'm going to shift I to this position, then this, and then this. Once the I would be at position 4, right, so there it would become equal to. Once it becomes equal to, then I am going to check this current word, right? So I can say s of I plus length of word if it's equal to my current word. So if it's equal to the current word, that basically means, right, that is code equal to lead. Initially it won't be, then we are going to remove lead and check if the code is equal to code, it is going to be true. Then what I'm going to do, I'm going to, so here, right, this is a dp, this array I can say dp. So dp of I is going to be the current dp I plus length of word. So if I go understand plus 1, okay, so currently my I would be at 4. So sorry, 4 plus length of word is 4, not plus 1, it would be length of word only. So 4 plus 4, right, it would be at 8. So my dp, I will change this current value to 1. Similarly, now we are going to check for the other one also. Here also you're not going to go to get a match, not match, and we're going to loop through, right? And once we are at this position, Then we are going to check the s of I, right? Then it is going to be lead is equal to lead. It is going to be correct. Then I can again go to this formula, and here, right, I am going to take from 0 plus 4. 0 plus 4 is going to be 4, right? Here the index is at 1, so I am going to say it is going to be 1. And at last I can say return dp of 0. So dp of 0 will only, here 1 will only come in case, right, you are able to form the word. So that is the basic idea, how using dynamic programming we can solve the problem of word break. Now let us jump to the Python solution where we're going to find the answer. And if I look into the time complexity of it, so the time complexity would be big O of the total would be length of word. So I can say uh, the total would be n multiplied by the current word that is present out here. So let's say it is 4, I can say m. And how many words are there, right? We have to compare with all of the words. So it would be like k. It would be a kind of a complicated problem, but with the help of dynamic programming we can basically solve this problem. Now let us jump to the solution. So here the first thing that we are going to do, right, we are going to find the length of s. So length of s. Then we are going to create a one-dimensional array which is going to be initialized with all of the 0 values. So dp equal to 0 multiplied by n plus 1. We have to also initialize the last value with 1 so that it denotes it's true, so that we can the base condition. Now what we can do, we can loop through. So for I in range n minus 1 to minus 1 and minus 1, and here I can add few more conditions, which is basically I can say if I have to also loop through the word, right? So for word in word dict, if I plus length of word is greater than n, it has to be less than, it has to be less than equal to n, then only the match is going to happen. And both of the condition needs to satisfy. So and s of I plus length of word, or I can do it in this way, word length, instead of calculating it twice, right? Let me just calculate it once. We can save some amount of complexity out here. So I can say I plus word len, and here I plus word len we have to do slicing. So equal to word, in that case we can say dp, and here I can say I equal to dp I plus word len. That's the idea. Now if my current dp of I, we can already made it true, then what we need to do, right, we need to just break it, because there is, means if it's already true, right, we can say that we can reach that particular index by forming some word, right? So then there is no point of going through all the words. So I can say break. So that's the idea. And at last I can say return dp of 0. Let me see if it works. Ideally, if there are no spelling errors, it should work. Let me check. Yeah. So the problem it is happening, right? I'm returning true. So I can say bool of dp of 0. So I think it should convert 1 to true. Let me check. Yeah, it converted 1 to true. You can also, instead of initializing with 0, right, you can initialize with true and false. It's up to you how you want to proceed. Let me run the code. As you could see, it is beating 79.61%. So it's pretty efficient code in that regard. So that's all for this video. See you in the next one.